Okay, so this is Google Collaborate. So when you open Google Collaborate through your Gmail account, I've already gotten some of your Gmail accounts. You will get this kind of interface where you can have access to Google Drive. You can also connect it to GitHub, which I think we're gonna work with GitHub towards the end of the semester. I'm just trying to work to try and get you access to like the student pro versions if you don't already have access to it. So I don't have that yet, but I'm hoping that by the end of the semester we can get some exposure with GitHub. You can also upload files and then you can have access to your recents. And they also even have example of what you can do with Colab. So markdown, charts. Uh, we might explore some of this towards the end of the semester, but for right now, we're just going to work with the notebooks that I've given you. And so the file that I think I've given you, I'm pretty sure I linked to you. Well, actually, maybe not. Here it is this copy of assignment 1 CIS W24. That .ipynb is a Jupyter notebook. So Jupyter notebook is like a combination of a markdown with uh with a Python, but for Python. I think you can even put other languages within Jupyter notebooks, but I haven't really played around with it enough to know for sure. But basically, if you go directly to Google Collaborate, this is what you'll see. If you click on the link and you have permission to access it from Blackboard, this is what you'll see. It's going to open up this Collaborate notebook. And this is an exam, and this is your first assignment for this week. Basically, the notebook is going to see that here we have this executable line of code. So I've basically assigned a variable. So what is a variable? It's basically a way of storing information for later. So here I have stored the number 1 as an assignment number, assignment underscore number, and then I have a print statement here for it to print. So when I click on that, it basically connects. If you look down here at the bottom, it connects to Python 3. It checks yes, it's connected, and then it runs the code. And it prints out 1 as your assignment number. And then what I do is I give you kind of like an explanation of what we're doing and then little blocks for you to fill out and complete on your own. So we're going to start real simple. You can't start programming without doing Hello World. So if you've never programmed before, you got to learn how to do Hello World first. So if I were to run Hello World and just write it into my executable line, I get nothing. And the reason why is I get a syntax error because I'm not basically writing it the way it wants me to write it. But the reason why it doesn't like that is because I'm not putting quotations around it. So what it's trying to do is it's trying to read it as one of those special words of like conditionals or true false statements, and it's just saying, oh, well, I don't know anything about hello. You haven't assigned a variable as hello. I don't know what hello is. I don't know what comma is. I don't know what world is. I surely don't know what exclamation point is. Is it a factorial? I don't know. And so that's why we get this error. So the next step is you need to edit it so that it works. So if we put quotations around this, it'll interpret it as a string. So I was actually going to play you a song, and basically you now have it actually printing out Hello World. So yay, once you do that, you get your first ever Hello World out of the way. And so with this one, it doesn't work. So you have to edit this so it works in the way that you want. And so you can have a string by either putting quotations around it if you just want to print it as such, or you can have a string, which is a list of characters, with str in front of it to basically give what you want expressed as a string. But also, and so when you combine it with an str around it, what it allows for you to do is it allows for you to combine variables and combine strings. But you do that through what's called concatenation. So if I scroll down further, we'll talk about concatenation, where I assign a variable to be stored for later. So I can call course number 186, and then I can put in a string, and then I can add them together with the plus sign to concatenate together, and then it prints out the welcome statement to welcome you to the class. So the three main things that you need to learn about today are basically the Hello World program, what are strings, what are variables, how do you concatenate them, and then just a couple of basic functions. So that's what your assignment is you're going to take this this Google Collaborate document in your own. I don't think have access to edit this. So what you're going to do is you're going to go to File, and you're going to save a copy in Drive. And then when you save a copy in Drive, it should just automatically make a new copy of it. So it says another copy because I already have one. Then what you'll do is you're going to edit the name of this. And this will say F24 because it's fall 24. And then you'll put your last name here. So my last name is Vote. So I put Vote there. And then you'll edit the file with all of your answers. And then you will go over to this share button here. And then you'll click on share. And then you'll change this to either anyone with the link. And then you send me the link. Or you can put restricted and you can put my email address, which my email address is going to be lvecon23@gmail.com. Or you can just do anyone with the link, and then what you'll do is you'll take the link, copy link, and then you'll paste that link into the answer box in the submission box for assignment 1. And then I'll have access to it, and then I will grade it. So the reason why you would use the print command traditionally is if you are basically running a full-on program where you're trying to basically have it do multiple things at the same time, or it's reading linearly down the lines. So when you build a traditional program, you're going to want it to do a bunch of stuff. And so you might want it to print something, so you put a print statement in to have it express that, and then it keeps reading. Whereas in this case, it's basically running in a terminal where it functions, but it's not really like reading in a program. It's not really doing anything other than the one single task that you're asking it to do. Once you start complicating things and adding things together, it's usually better to use a print statement than just printing it with the string in text in quotes. But I'm just trying to give you kind of exposure to the different ways in which it expresses itself. But the more you complicate things, the more you add functions in, classes in, you make more detailed programs, you're going to kind of want to use print commands more. So again, variables are basically there to allow for you to save things in memory for later. So you can call a variable X, you can make X5. You can make X your name. You can make X Twitter. I don't care what you want to make X. But whatever you make X if you define it with an equal sign, it will store it as that. So if I click on this and I define X as 5, and then I have it express X, it's connecting to the server. It prints 5 when I ask for X. If I change and redefine X, so if I do this and I go, okay, X equals 9, and then I print X, what it'll do is it'll print 9 because I changed it, and it overwrites the previous variable. So you don't want to do this unless you intend to get rid of and replace the original value of the variable. And then, so you can just express X, or you can print X. You can do a print statement. You can even change X from a number to a string. and say, okay, well, X equals Muskegon rocks. And then when you click on that, X was 5. And then when we rechanged X and expressed it, it's now a string, Muskegon rocks. And then you can piece these things together through concatenation with plus signs within print statements. So you can combine a variable and a variable. You can do math to do math functions with variables. So if both of the variables are integers or numbers, you could just multiply x times y. So if x was 5 and y was 2, you could do x times y, and it would give you 5 times 2, which is 10. However, if you try to do x times y and it's 5 times Muskegon rocks, it's going to give you an error because it's trying to do what it thinks it's supposed to do, where it's doing multiplication, but it doesn't have compatible data types. So one thing, so again, a lot of this is also explained in kind of, it's not really comments, because if you want to do comments in Python, you just do a pound. I am leaving a comment here. And then that's your comments. These are actually like, this is like a markdown file. So this is outside of the actual code line. And then there's kind of explanation almost going through and walking through all these things. And then one last thing that I want to mention that one of these problems is going to address is that one of the most important aspects of programming, and maybe you've learned this in other classes and maybe you haven't, but particularly as it pertains to data science problems, but even just in software development in general, you want to make code that generalizes. So I could ask you, what is 5 times 2? And you can either have it code to basically solve 5 times 2, or you can just solve it on your own and say, well, it's 10. The first one is basically building a program that's applicable if you basically request for X to be a number, Y to be a number, and then it multiplies the two numbers together. But if you just submit the answer as 10, that is what we call hard coding. Hard coding basically results in it telling you what the answer is, but when you get into a career in software development or programming, you want to reuse code a lot. And you want it to be generalizable so that way you can use it for one case and you can use it for another one and all test cases. So later on in the semester, when we start doing more real programs, one of the ways in which your grade is going to be based on is the generalizability. So it might work for the example that I give you, but I might have a secret test case that it doesn't work for. And if it doesn't work for that case, it's not ready. It's not finished. So it might be enough to pass if it satisfies the condition that I'm requesting, but it might not be an A because it's not generalizable. And that is where programming can be very time consuming. It works for a couple, but it doesn't work for all, or there's one little typo that you did and it keeps the whole program from functioning. This is known as debugging,